to talk about reference triangles. Our reference triangles are always with respect to the x-axis, and essentially we are always thinking about how far are we from the x-axis each time. And the thing is, with these reference triangles, any angle measure that has that same reference angles from quadrants 1, 2, 3, or 4 will all have the same x comma y value, just depending on whatever quadrant you are in will dictate if those values are positive or negative, due to the fact, think about like location. Are you moving to the right and up, or are you moving to the right and down? So again, each of those will be in depending on the quadrant you are in. Now, our reference angles are always positive numbers from either 0 to 90 if we're dealing with degrees, or 0 to pi over 2 if we're dealing with radian measure. So if we look here at some of these examples, again, you are always thinking, how far am I from the x-axis? So oftentimes that's going to be, how far am I from 180, or how far am I, if I'm in quadrant 1, from 0, or quadrant 4 from 360. So if we draw in our reference triangle in number 1, we're at negative 170. So essentially we're thinking, how close am I to negative 180? Well, we are 10 degrees away from that, so that would be the size of our angle measure, or of our reference angle, positive 10 degrees. And the second one, if we draw in our reference triangle, again, we're thinking, how far am I from the x-axis? In this case, the closest x-axis measure is again 80 degrees, and we are 30 degrees then away from that measure. Number 3 starts asking us about looking at radian value of this. So in this one, again, even though we're going around more than one time, we are really drawing again back to that axis. And again, we're coming up with a angle measure that's between 0 and pi over 2. Now, it may be easier to look at negative 29 over 12 with respect to its coterminal value that's between 0 and 2 pi, because again, the reference angle measure would be the same. So think 19 pi over 12, right? And if we think about in terms of our reference angle, if I'm at 19 pi over 12, that closest x-axis value is going to be 2 pi. Or for an angle with a denominator of 12, that would be 24 pi over 12. So essentially we're thinking, how far away is 19 pi over 12 from 24 pi over 12? Well, they are 5 pi over 12 away. That's going to be the size of our reference angle. Another one to look at is number 4. Number 4, again, if we look at that, is again asking us to look at how close we are to the x-axis. This time our closest x-axis value is pi. And again, 25 pi over 9, it might be a little bit easier to look at this with that reference angle between 0 and 2 pi, in this case, 7 pi over 9. And if we are at 1 full pi and our denominator is 9, that's the same thing as saying 9 pi over 9, right? That's still 1 full pi. We just see this denominator value of 9. So 7 pi over 9 and 9 pi over 9 are 2 pi over 9 away from each other. So that's how big this reference angle here is going to be, would be 2 pi over 9. Our last one over here, again, negative 61 over 18. It's awfully small. If we bring this back to being between 0 and 2 pi, if you math enter, we end up with this being equivalent to 11 pi over 9. So, 11 pi over 18. Now this is helpful because if we are at 11 pi over 18, it's a little bit easier to see, okay, my reference angle, if I want to be at 1 pi, my denominator is 18. To get from 11 to 18, it would take another 7 pi over 18. So that's my reference angle this time and how far we are away from that x-axis. Right, now sometimes they don't give you a picture when it comes to finding these reference angles, but that's okay. We can kind of use the same idea and think about, okay, if I'm at negative 743, again, I'm going to add 360 a couple of times to make this into a positive value that's easier for me to kind of deal with. In this case, 337 would be a coterminal value to that and have the same reference angle size. And 337, we know, is in quadrant 4, and the closest value would be 360 degrees. Well, 337 is 23 degrees away from being at, say, 360. So 23 degrees would be our reference angle. 8 pi over 9 is a quadrant 2 value. And if we are at 8 pi over 9, our closest x-axis value is going to be pi, or in this case with the denominator of 9 pi over 9. And to get from 8 pi to 9 pi over 9, we would need 1 more pi over 9. That is the measure of our reference angle. 22/3 then, if we convert this back, again, I'm going to shrink this down to be between 0 and 2 pi. 1.3 repeating pi is 4 pi over 3. 4 pi over 3 is a quadrant 3 value. And again, closest value of pi would be 3 pi over 3. That's our closest x-axis. And again, this time we are 1 pi over 3 beyond that to be at 4 pi over 3. Try 147 on your own. Find the reference angle there. Right, now the last part of today is using some trigonometry to find ourselves the length of our hypotenuse of these reference triangles, or each of the two legs, or find the theta measure. So a reminder, we can use a combination of trigonometry. We may also use some Pythagorean theorem to help us with some of these pieces. Remember, hypotenuse is always your C, and then your two legs are your A's and your B's. In number 10, they are telling us we have an angle at 142 degrees. So that would be like this, right? Would be the 142. So into quadrant 2. And this time we have a segment named O to P. O is the origin. P is this point out here on our triangles. And we are trying to find the coordinates of P, aka the X, comma, Y. So in this case, we would, if we're in quadrant 2, we would end up moving to the left and up. So we want to be careful because our final answer should have a negative x value due to that quadrant 2 location of 142 degrees. Now, the first things first, we need to figure out what is that reference angle. And we are 38 degrees short of 180, so that is our reference angle. And again, they gave us that O to P is 14, so we have this length of the hypotenuse. So in order to find our x-coordinate, we can use cosine, because we have the adjacent and hypotenuse. So cosine of 38 degrees equals the adjacent over the hypotenuse. Multiply both sides by 14 to get our value of x. 14 times the cosine of 38 is about 11.03. Now also double check at this time that your calculator is in degree mode, because we use 38 degrees. You want to make sure your mode is in the degree mode. So 11.03. Now to find our y value, that is the opposite angle of 38 degrees, and we have that hypotenuse again. So to find the y coordinate this time, we're going to take the sine of 38 degrees, which is opposite over hypotenuse. Again, multiply both sides by 14, and you should get 14 times the sine of 38 for a total of 8.62 for that y value. So each time, cosine will always go with your x, sine will always go with your y. Now again, when we think about our final answer for this point, we're in quadrant 2. So when we write our final answer, we would actually write it so that it's negative 11.03 since we moved to the left, positive 0.862 since we moved up to get to point P. Now our next example is asking us to instead kind of go the opposite direction. We are finding theta and O to P. And this time we move to the right 5 and down 7. So that puts us into quadrant 4 this time. And again, we don't know the length of O to P this time. We also don't know this theta measure here inside of our angle. So when we are thinking about this, again, a lot of this is going back to our geometry days where we are thinking about our right triangle trick, right? And in this case, we have the side lengths of 5 and 7. We are looking for that hypotenuse value. So c squared equals a squared plus rb squared. And in this case, we would take 5 squared plus, make sure you're using parentheses, negative 7 squared, or you could just use 7 squared, and we would get 74. So you would say either if you want the exact answer, square root of 74, or the approximate answer of that, which is about 8.6. So this is going to be our length of O to P on that triangle. Now, if we think about our theta value this time, we're also going to use some trigonometry, because if we use theta, we have the opposite leg given and the adjacent leg given. So tangent would be very useful to us because we have opposite and we have adjacent. Now, be very careful. What we're going to do on this is we are going to change this to the positive so that we can make sure we get this angle measure, thinking about for the sake of being the reference angle here. So in order to get this in the calculator, we're going to take tan inverse of, again, positive 7 over 5, so we can get that quadrant 1 value. Tan inverse of 7/5 would be 54.5 degrees. Now, if we were looking for what the actual quadrant 4 angle is, we can kind of work backwards and say, okay, 360 minus 54.5 would give us that quadrant 4 value of 305.5. So if you needed to work backwards to find that, you could also do that. However, this one was just asking for that measure of our theta inside the triangle. All right, thanks everyone for watching. We will definitely work more with these in class.